Hey everybody, we're doing 9.3, determining similarity today. So in 9.2, we were given that some triangles were similar, but now we're going to find or determine if two triangles are similar. Okay, so just a quick recap: if two triangles are similar, then we know, this is what this says, triangle ABC is similar to triangle DEF if corresponding sides are proportional. So these are the proportions, okay? And corresponding angles are congruent. All right, so in order to determine similarity, we need to tie back to this definition. We don't need to show all of this for every set of triangles, but we do need to show enough so that the rest of the information can be assumed. All right, so for example, if we know what D and E are and that they are congruent, then we know that these have got to be congruent, okay, equal. So something like that where we don't need all the information, but we need some of them. So for just example, what we're talking about is angle-angle similarity. All right. If two pairs of angles are congruent, the last pair also is congruent, and the triangles are similar. Okay. When should we use that? Okay. We should use that if we have two pairs of angles that are given. So this is a great example where two of the angles for both of them are given. They don't both need to be the same, all right? Because if we know that triangles add up to give us 180, we could come up and say, well, 180 minus 59 minus 37, okay? And that would end up giving you 84, okay? So we know that we have two pairs of congruent angles. And if we have two of those, then we know that the third is also congruent because triangles add up to 180. Okay, so that is one example. We also use this when we have a pair of angles and vertical angles. So like here we have vertical angles. And also when we have parallel lines and two transversals. So let's talk about these individually. So first off, we have two triangles. They give us, telling us what these angles are, which ones are congruent. So angle L is congruent to angle D. Sorry, one sec. Okay, so angle L is congruent to angle D because they have the same like symbol. And then we know that like angle K is also congruent to angle E. So since we have two pairs of congruent angles, then we can say that these two triangles are similar. And so we'll say similar, and we'll say why by angle similarity. That's kind of a symbol that means similar. Okay, and then we need to fill in the similarity statement. So LK has got to be pairs up with DE, and then what's left is our J. Okay? And how we know that those two, that LK and DE, are like corresponding sides because they share the same angle. All right, here's another example. Here we have vertical angles. That means we know that these two angles are congruent, that they're the same. So now we need to say we know that angle R is congruent to angle R, and probably to be more specific, we should say like angle TRS is congruent to angle DRE. Okay, so we know that those are congruent, so we know which one is which. All right, but then we need to also find one more pair that is the same. Well, we have 70, or I guess maybe we should do this one. 73 has got to match with one of these two, and neither of them do. So here would say not similar. And if it's not similar, we don't need to come up with the similarity statement. We don't need to say how we're proving it by like side or angle. Okay? Here's another example. These little triangles, that means that they're parallel, which means that this angle is a transversal. And that tells us also that these two angles are congruent, because by alternate interior angles. So like before, we've done like something like this, and we said this angle is congruent to this angle because they're alternate interior angles. So angle F and angle L are congruent. And if we need one more, so we could know that these are the same also for the same reason. So we know that angle K is congruent to angle E. But we also know that these are vertical angles, so we could use those as well. But we only need to find two, so we could say these are similar, okay, by angle, similarity, and we need to finish the statement. So, I guess maybe I should make those three because they're the same. So we have LK has got to be similar to, or proportional to, EF, and then we need to finish that up with a J. Let's make sure we got this right. So KL is, maybe we'll use a different color. KL, JK, sorry, I got those off. 1 second, okay? Try that one more time. So we have JK is this side. I got that off. Okay. And that's the one that is between our vertical angle and where we have two angles. Okay. So then that must also be proportional to this angle, where we also have the 3 and the 2. So we need to do, we did J to K, so we need to do J to E, and then to F. Okay, that one was a little tricky, mostly because we don't know the sides or anything. It makes it a little easier when we know the sides. Okay, if you have questions on that, let me know. Sorry, that was probably a little confusing. All right, next we have side angle side similarity. So if two pairs of sides are proportional and the angle between them are congruent, then the triangle is similar. Okay, so we'll use it in a situation like this, where we have two pairs of proportional sides, and we also have an angle, two congruent angles that are between those two sides. So again, these are vertical angles, so we know that angles are the same. So we could say that, I guess we don't need to write those down, but we do need to make sure that they are proportional. So here it looks like we could do, this is the larger number, and that its corresponding side should be also the largest side for the other triangle. So we could do something like 6 over 12, or maybe we'll do it the opposite way because I kind of like that better. 12 over 6. Okay, so this corresponds to 6, and 10 corresponds to 5. And if they are proportional, then they should be equal. So this should be 2 equals 2. So we're good to go. So these are similar triangles. All right, so let's do a couple examples of that. We know that these angles are the same, so angle L is congruent to angle E. And we also need to find that the sides next to those are also congruent. So we need to find their corresponding sides. So maybe we'll do largest to largest. Oh, but right away I can see that these two are the same. If the 9s were the same, then this should be like a 27, and this should be a 27. So right away we could say not similar. Okay. All right, let's try this one. So again, we have vertical angles, so we know that these angles are congruent. Now we just need to find that the sides, the corresponding sides, are proportional. So again, I like to do largest to largest. So maybe 30 over 10 should be equal to 27 over 9. And if we do that, I think we end up getting 3 equals 3. So they are proportional. So we can say similar by side angle side. And we need to finish out the statement. So we did A for here, we did ABC, ABC. So we need to do the same. We need to make sure we use the same corresponding sides. So that would be AVU. Okay. So we should make sure that A and B and A and V those are the corresponding sides. Okay, here is a triangle inside of a triangle, which means that these two share the same angle. So we know that the angles are congruent. Now we just need to show the proportions. So we could do something like, maybe we should write a second picture. So we have a big triangle. We need to maybe add those together. That would give us 62. And then we have these two together. That gives us 77. And then we'll have our smaller triangle where we would have 54 and 66. So now we need to show that they are proportional. So we could do large to small. So maybe 77 over 66. And then we could do large to small, 62 over 54. If you simplify that, I think you end up getting 1.17 for this ratio, and for this one we would end up getting 1.15. So these are not similar. Okay, the proportions or the corresponding sides are not proportional. All right, and I think this is our last one, is side, side, side. So if all the sides are given and that they are proportional, then the triangles are similar. So you'll do this when you have all three sides that are labeled in all three. Okay, so we'll maybe skip this example and we'll just go into this problem. So they don't give us like a similarity statement, so we can't really compare using that. But again, if they are similar, then the largest side should correspond to the largest side of the other triangle. So we could do, maybe we'll do big triangle over small triangle. So we could do something like 55. Actually, let's do it the opposite direction. Let's do it this way. It doesn't really matter. So 42 over 55. And then the next largest would be like the 33. That should correspond to the other next largest. So we'd do something like 33 over 44. And then we could do 23 to its smallest, which is 32. Okay, looking at the fraction, it's hard to tell, so really we should write it as a decimal. So just divide all those fractions and we should end up getting 0.76 and 0.72 and 0.75. So none of them are equal to each other. If any of them aren't, if just one is not the same, then it's not similar. So here it would say not similar, and we just go on. All right, here's another. We have, for this one, we could do it two different ways because we have two sides with a shared angle. So that you could do side, angle, side. But since we're doing side, 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 let's try side, side, side. Okay, so you could write these separately if it helps. We could make a big triangle here. This would be 70 and 55, and then we have a smaller triangle, which is 42, 30, and we'd need to figure out what this is. We'd do 55 minus 12, or 22, sorry, that should give you 33. And now we can come up with our proportions and make sure that they're the same. So we have all three sides, we have to do all three proportions. So we could do large to small, so 50 over 30, and then we could do this one goes to that one, so 70 over 42, and then 55 over 33. And we could use our calculators to kind of get these decimals. We'll end up getting something like 1.67 equals 1.67 equals 1.67. You got to check all three. So they are similar by side, side, side. And we need to come up with the statement. So KL, where's our KL? So this big, the big side of the triangle, that should correspond with our KC. And the next one is LM, so this part should correspond to this one, so CD. Okay? All right, so all we have left is just some examples. I think it's a good idea if you could pause and do these 6, and then just kind of skim past the answers and make sure you get it. Okay? All right, so let's start by looking at A. They give us all three sides for both triangles, so if it's going to work, it's got to be side, side, side. So to do that, we need to show by doing our proportions, all three corresponding sides. So again, I think it's a great idea to do like largest to the largest. So 72 over 27. And then we could do the next largest. That looks like we would do 29 would go to the 18. So 49 over 18. And then we have our final one, which would be 40 over 16. And then we can use our calculators. 42 over 27, that gives you 2.67. And then 49 over 18, that gives us 2.67. So it's looking good. And then we could do 40 over 16, that gives you 2.5. Oh. So that means that it is not similar. And then we don't need to write down the statement. All right, here's another example. So how could this work? Well, it looks like we have two sides and we have vertical angles. So maybe side, angle, side. And we'll need to check for the proportions. So maybe something like largest to largest. So something like this. So we could do 16 over 40 is equal to 10 over 25. Simplify that. Looks like we get 0.4 is equal to 0.4. So then we can say it is similar by side, angle, side. And we need to write down the statement. So I think we said that 16 corresponds to 40. So DC corresponds to DT. All right, and then next we have CB, which is here, it should go to here, so it goes T to U. All right. Okay, here's another example, an angle inside of an angle. So we know that these two share the same angle. So again, it could be side, angle, side. So maybe think about that and see if it works. So I'm going to draw these two triangles, maybe the smaller triangle, which was 42 and 30. And we don't know what this angle, but they share the same angle. And then we'll do the larger triangle, which we need to add those together. That would give us 56. And they tell us it's 40 here. So now we need to come up with those proportions. So we could do, looks like 30 corresponds to 40. So we could go 30 over 40 is equal to, and then we could use for these two. So 42 over 56. Simplify that, we get 0.75 is equal to 0.75. So we know that it's similar by side, angle, side, and we need to finish our triangle or our similarity statement. So CD is this side, so it's going to compare or correspond to CG. So CG. And then we'll go DE, so that corresponds to GF, or H, sorry, GH. Okay, let's give this one a try. It looks very similar. They share the same angle, but they don't give us the sides, but they do give us two angles, and they are the same. So we have a shared angle, and these two angles are the same. So we can say that we have two corresponding pairs of angles. So this would be similar by angle, angle. And then we need to come up with the statement. So again, make sure you always put the triangle there. And it looks like we'd get DKL. So this would be DCB, DKL. All right, two last ones. Again, we have a shared angle. It looks like we also have enough information that we could do side, side, side. So maybe we'll do side, side, side since we do lots of side, angle, side. So we could write down the two separate triangles if you'd prefer. Okay, so this is 11 and 5. And we'd have to use some math to come up with this, but that ends up giving us 12. And then this whole thing we said was 77 and 76 and 35. So now we need to find the corresponding sides. So this corresponds to this. 76 divided by 11 is equal to 35 divided by 5. And 77 over 12. We get our calculator out. So 76 divided by 11 looks like it gives us 6.9. I do this? Hang on one sec. Okay, and then we could do 35 divided by 5 gives us 7, and 77 divided by 12, and that gives us 6.42. So these are not similar. Unless I made a mistake. I'll have to go check and see if I did. So I'd say not similar. Okay, yes, they're not similar. All right, now we'll try this last one. So this one's kind of easy because we don't have any numbers. This tells us these are parallel. And if they're parallel, then we have, we know that these angles are the same. all right? And we also know that these angles are the same. And we also know that this shares the same angle. So we could say similar by angle, angle. And its statement here would be, so it goes JKL, so we'll do JEF. Okay. All right, well, if you have any questions, let me know, and we'll see you later.